Okay, so we've been talking about parallel lines. Now, we have to try to prove that lines are parallel. You can't just look at them and just assume that they are. So we have postulates and theorems that are provided in your online textbook, and it lists the actual postulate or the theorem, how it works with your hypothesis, and then the final conclusion. So for example 1, what they are asking is for you to prove, based off of the information that you're given, that line L is parallel with line M. So what we're going to do is look at the measures that are given. They've given us that the measure of angle 1 is equal to the measure of angle 3. Well, is that true? Let's look at it. So angle 1 is shown here. Angle 1 is shown here, and angle 3 is shown here. So we talked about this the other day, the type of angles that these are called. If I were to take line L and pick it up and place it on top of line M, I will notice that on top I have an angle 3. On line L I also have an angle, but this time it's angle 1. If I put them on top of each other, they are considered corresponding angles. Corresponding angles are, in fact, congruent. So, based off of me knowing that corresponding angles are congruent, I can actually prove that since these are corresponding angles, and I'm going to abbreviate corresponding angles, then I can prove that line L, based off of this is what I'm looking at, but this is my conclusion if I'm looking at the postulate, that line L is indeed parallel to line M. And why? The reason would be because of the converse of the corresponding angles postulate. So that's what you would write when you're trying to prove something. Converse of the corresponding angles postulate. So that's it. You just prove that line L is in fact parallel to line M because you proved that there are corresponding angles that occurred because of transversal cut through those lines. Let's try another one. So this is a list of other theorems that we've talked about. Actually, these are the converses. We've talked about different angles that are formed when you have two parallel lines cut by a transversal. So the two parallel lines shown here are line R and S, and the transversal is cutting through. We're trying to prove whether or not those angles that are shown are actually causing these two lines to be parallel. So the measure of angle 4 is congruent to angle 8. Let's see if that's true. There's 4 and there's 8. So here we have the converse of different types of angles, but if you just read in between, in the middle, it tells you those different types of angles. So we're trying to decide whether angle 4 and 8 falls into one of these three categories. So if you can't tell by reading the actual theorem, by looking at the words, look at the pictures. Which one looks more like angles 4 and 8? That's correct. Alternate exterior angles. Alternate meaning that it's on the opposite side of the transversal. Exterior meaning it's on the outside of your parallel line. So we know that these are called alternate exterior angles. And I am trying to prove that line R is parallel to line S. And again, I would look at the converse theorem that tells me that this is true. It says if two coplanar lines are cut by a transversal so that a pair of alternate exterior angles are congruent, then the two lines are parallel. So based off of that converse, I know that these are in fact congruent. So again, if I were having to explain why, I would write the converse of the alternate exterior angle theorem tells me that line R is indeed parallel with line S. So one more example, which is not proving, but I do want you to understand how to find, if you're given two variables, how to find those variables, especially if you're given this symbol. This symbol tells you that you have perpendicular lines. This is 90 degrees. So if one angle is 90 degrees, by default all of them will be 90 degrees because of your linear pair, vertical angles, same side interior. Well, I'm sorry, same side interior is going to equal 180, but if I were to take this one, this angle, and pick it up and place it down here, this is going to be 90 degrees. So based off of just knowing that, what I would do is I would focus on the variable that is just single. I wouldn't focus on the one that has two different variables. So I know that this is a linear pair. I also understand that when I'm talking about a linear pair, that I can set them equal to 180. So 3x plus, again, I understand that means 90 degrees. And since it's a linear pair, it's supplementary. So two angles added together will equal 180. Now I just solve for x. So I'm going to subtract 90 on both sides, which will leave me with 3x is equal to 90. And now I'm trying to solve for x. So I will divide both sides by what's stopping x from being by itself, which is at 3. X becomes 30. 90 divided by 3, that's 30. Now I want to find the y. So I could do it multiple ways, but what I'm going to do is I'm going to take my x and I'm going to replace it here. And again, I understand that this is a linear pair. You do not have to do it this way. We can actually use the fact that they're corresponding angles and set them equal to each other. It's up to you. All right, so x plus 20y is equal to 90. However, x we said is 30. So 30 plus 20y equals 90. And now I want to get y by itself, so I'm going to start undoing things. First thing I want to do is get rid of the positive 30 by doing the inverse, which is a negative 30. What I do to one side, I do to the other. And so I'm left with 20y is equal to 90 minus 30, 60. Now I need to find y. In order to do that, I divide both sides by what's stopping y from being by itself, which is 20. Now, y becomes, I can get rid of those zeros, 6 divided by 2 is simply 3. So I have found both x and y. Well, let's verify that. Let's prove that that's true. I know that they are supposed to equal each other because, again, they're corresponding angles. So this angle is supposed to be congruent to this one. So let's see. 3 times x, well, x is now 30, is equal to, and again, x plus 20y. X is 30 plus 20y is 3, based off of what we just found. And let's see if it does, in fact, equal on both sides. 3 times 30 is 90. 30 plus 20 times 3 is 60. And so when I further simplify, 90 is equal to 30 plus 60, which is 90. But we already knew that. We knew all angles should be 90, so these are my correct answers. So make sure you understand what type angles you're working with so that you can easily solve for different variables.